In today's lesson from Unit 2.1, we'll be taking a look at transformations and congruence. For a warm-up, just take a few minutes and graph the triangle with the vertices at point A, which has coordinates 1, 4, point B at 3, -2, and point C at -1, 1. Next, transform each vertex of the triangle using the rule, which maps every point xy to a new point by doing x minus 2 and y minus 1. Remember that x minus 2 will shift every point to the left 2 units, and y minus 1 shifts every point down 1. So take point A and shift to the left 2, 1, 2, and then down 1. So A prime will be right there, and it has coordinates -1, +3. Do that for point C. So left 2, 1, 2, down 1. So C prime now has coordinates -3, 0. And for B prime, start at B, go to the left 2, down 1. So B prime is now at 1, -3. So take a second and connect those points to make a triangle. So the first question is what type of transformation is this? And it's a translation, because we're sliding every point in the pre-image, the blue triangle, to the left 2 and then down 1. The next question says, are the pre-image and image congruent? The answer is yes. They have the same size, same shape, so they are congruent to each other. And the final question, in which other transformations are the pre-image and image congruent? In other words, which other transformations are what we call isometries? So, if we think about reflections, a reflection would keep your pre-image and your image congruent to one another. A rotation would create a congruent image. And finally, we have a glide reflection. That's where you move your pre-image left or right, or up or down, and then you do a reflection after that slide. All of those things that we just described, reflections, rotations, glide reflections, and translations, are what are called rigid motions. So a rigid motion is a transformation that preserves length and angle measure. And we should also say that it preserves area. And this is because when you take a figure and you perform a rigid motion, such as a translation, your two figures are congruent, so their size and shape stays the same. So notice what was not on our list, and that's a dilation. Right? Dilations are not rigid motions. And this is because in a dilation, your figure, your image, changes size. So a dilation would take a triangle and either enlarge it or shrink it, depending on what the scale factor is. Next, we'll take a look at 4 transformations. It says, if the transformation illustrates rigid motion, identify the type of rigid motion. So in the first one, every point in triangle FED is mapped to a new point in triangle F prime, E prime, and D prime. So if you take a look at what's happening here, those points are being mapped like that. Imagine if we drew a line right down the center here. Can you see how this would represent a reflection? And a reflection is a type of rigid motion. So it's a reflection in some vertical line. If you take a look at number 2, we have to be a little bit more careful on this one. We're taking triangle HIJ and mapping it to this new triangle. Let's see if you can figure out what type of rigid motion is happening here. Notice that the triangles are congruent. The size has not changed at all, so it's definitely a rigid motion. But thinking about going from point I to I prime, we're talking about a rotation. And you can kind of twist your paper around to see how that would work. All right, our third example, we're taking triangle KLM, the little triangle, and transforming it into triangle K, and it should be K prime there, L prime, M prime. So the first thing that I notice is that the two triangles are not congruent. And if the two figures are not congruent to each other, it's not rigid motion. Because the size has changed. All right, so in this case, what we're looking at is a dilation. Okay, so dilations do not preserve length, and that's what's happened here. KL is not congruent to K prime L prime, so distance is not preserved or length is not preserved. Therefore, it's not a rigid motion. Okay, and our last one, number 4, is showing a couple of steps. So we're going to start at this triangle ABC, and then everything is shifted to the right, and it becomes A prime, B prime, C prime. So that's a glide, or a translation. And then everything in triangle A prime, B prime, C prime is mapped to a point in this triangle down below the line. A double prime, B double prime, C double prime. If you take a look at all three triangles, they're congruent. So what we have going on here as far as rigid motion goes is a glide reflection. Okay, next step is to work on the check your understanding, number 3. And as always, let your teachers know if you have any questions.